Displacement of a particle moving in one dimension under the action of a constant force is related to time by the equation T is equal to root x plus c, where x is in meter and t is in seconds. Find the displacement of the particle when the velocity is zero. Okay, so very good question. It's a bit good because it's a bit different from the questions we're doing so far. So we've been given that time is equal to root x plus 6, right? Which implies that t minus 6 is equal to root x. Now, if you square, let me mark this as equation number 1. And if I say squaring equation 1 on both sides, what do we get? T minus 6 the whole square is equal to root x the whole square. T minus 6 the whole square is t square t square plus 36 minus 12t is equal to x, right? So we basically have the equation x is equal to x is equal to plus 36 minus 12t. Now, if this is x, what is dx by dt? Dx by dt will be equal to d by dt of t square plus d by dt of 36 minus 12 into d by dt of t. What is dx by dt? Dx by dt is velocity, that is v. Derivative of 2 square is 2t plus derivative of 36 is 0 minus 12 into 1, which means velocity is equal to 2t minus 12. Now, what has been asked in the question? The displacement, the velocity is equal to 0. What is asked in the question? The displacement when the velocity is equal to 0. So, if velocity is equal to 0, then we can say that 2t minus 12 is equal to 0, in which case 2t is equal to 12 and then t is equal to 6 seconds. Now, if t is equal to 6 seconds, what is x is equal to? X was given as t square plus 36 minus 12t. Now, when t is equal to 6 seconds, what would be x equal to? X would be 6 square plus 36 minus 12 into 6, which is equal to 36 plus 36 36 plus 36 minus 72, which will be equal to 72 minus 72, that is x is equal to 0, in which case the displacement is equal to 0, and which further means that the object has reached the initial position back in the motion. So the correct option here would be option D, which is 0.